So if you want to go to Pacific Hackers, start on Friday and Saturday, email Irvin. He can get you in for free if you volunteer to help with the conference. So check that out. And all right, so this is 128. And we're down to the last chapter about Android, which is securing Android applications. So over here, there's not much left of this course. There's this, and then just a few more classes, and then the last class. And I made the last quiz extra credit. You don't like having anything required at the end of class. And you should be able to see what your grade is going to be and plan for it. If you look on Canvas, there's a chart showing how many points it takes to get certain grades. And so nobody should be surprised at their grade, and you still have plenty of time to do something about it if you want to, if you're not happy with what you have so far. All right, so let's talk about the security issues of Android apps, and this is, to some extent, sort of a review of what we covered before, just from the other side, the defensive side. So here's the common vulnerabilities: code injection, logic flaws, insecure storage, and other things like logging. So in general, you want the principle of least exposure. You should just not have any more exposed areas. They call this the security boundary attack surface. I think you call it a CAC surface, that's the word. If you have ways to send data into your app, every one of those is a possible way to attack your app. So you should not have any open doors leading into your app that you don't need. That's least exposure. And then we'll talk about these other techniques. So principle of least exposure. You should find all the entry points and remove all the ones that are unnecessary. And any place that is necessary, you should make sure and test the data that is coming in to make sure that it's not attack data. So you have your app components. Remember, we talked about this. Drozer has this thing to find the attack surface, but we can do it just by looking at the manifest. So this is the most secure way to have it. You have one activity exported, which is the startup activity. You have to have that or nobody can launch your app, but then nothing else exported. This means that there's nothing else available to take any data directly from the outside except just to enter, and then you use data inside your app. This is the most safe way to do it. Now, you may have a reason to accept data from other apps, but if you do, you export them, and then you have to check the data that's coming in and make sure that it's not malicious. You shouldn't be storing data on the phone that doesn't need to be there, like passwords. A lot of people do store private data just directly in the apps folder, and of course, if the Android security model works, then the other apps will not be able to see that data because they run under a different user account, but the problem is there are many privilege escalation vulnerabilities, so people can escalate to root and then they can go over there. So that's defeating a sandbox. And if you put anything on the SD card, that's less protected. It used to be wide open to everything on the phone. Now, not quite everything, but still an unsafe place to put secrets. There is a perfectly good place to put secrets. There's a keychain. An Android, I think there's a different name for it, but there's an official operating system provides a secure place to put secrets if you want to put them there, which is far better than putting them in your apps folder. Then, of course, you might have inputs coming in from the SD card, internet, Wi-Fi, and Bluetooth. If you take any signals from them, then you should make sure that they are authentic with a signature or encryption to make sure they come from your trusted source, or check them in other ways to make sure that they're not malicious. And if you're loading anything, classes or executables, the code that goes in your app, again, you're going to have to validate that, make sure it's trusted input and it's not malicious. The best thing, of course, is cryptographic protections like digital signatures that make sure that, or hash values, that sort of thing. So you shouldn't have any more permissions than you need to have in your app. We talked about this. When you install the app, it'll tell you what permissions it needs. The really risky ones are install packages or running as system. Then that's really dangerous. Then this app can be used to install malware. So those ought to be avoided. And if you do use them, then you've incurred a large security obligation to secure your app against malicious use of them. The APK is a container, and it can have extra files in it. Your developers might accidentally leave files containing secrets in there. It will just get zipped up and included with the app. So that's a thing to be aware of, just like it happens in GitHub repositories and on Amazon buckets that people leave things in there without realizing that the end result is going to be public. And so you can trace these functions. If the entry points, if you have an activity, then it's going to have an onCreate method is the first thing it's going to launch. So that's what you should look at to see if it's going to take data that came in from the intent that launched the activity, and that data might be malicious and have an unusual effect. Here's receivers come in, content providers have queries, and so on. So these are the methods you should check. These are the methods that directly receive data that comes in when you use these services. you export components, you can limit them with permissions. This is a good idea. Then only apps from your company will be allowed to use them, and that's a lot safer than letting the whole world use it. If you really offer something for the whole world to use, then you have to be very careful. All right, so to secure an activity, you might want to prevent people from seeing that little image. You know, when you close an app, there's an image of it that appears in the thumbnail image that appears in the recently used apps list, and that might have a secret on it, like a password or something. So you can add this code to show that it will just be a blank screen there for your app instead, not including any data. And you can also remove it entirely from the most recently used list if you like. Tap jacking, we've talked about. This is where you draw a picture on top of something, so people click on the picture, but the taps are going through and clicking the thing behind it. It's a social engineering technique, and you can prevent it. You can prevent touches from being sent through elements with this by adding these to your, I think these go in your manifest. And so they go somewhere in your code anyway, and they would prevent your app from accepting taps that have passed through other objects. There's a dictionary. When people store words, it gets added to the spelling dictionary. Unfortunately, you might put your passwords and other secrets in there. So if you have an input box and you don't want it to go in the dictionary, then you put this attribute in it to prevent that. And fragments. I thought this was pretty interesting. I looked this up again to get this more fresh in my mind. I use fragments on my website. Fragments, if you have a page, like my pages have a big long page, and there's a link at the top that jumps down to projects or jumps down to lectures, that's what fragments are for. You get to name a location on a page and jump to it. And the same thing's true of Android activities. You can have an activity, and you can have a fragment that jumps to a piece of the activity. And the problem is each of those are sort of like a different activity, so there are vulnerabilities that can be associated with that. And so that means there was an attack here where you could jump to, there was a well-known attack. In fact, it's on this page. Let me bring it up. In 2012 or 13, they found a serious flaw in Android related to these fragments. All right, fragment injection. And what happened is, so you have an activity, but this activity just has one thing, but there are fragments inside the activity, sub-activities you can call, and they found that you could jump to the password reset activity, and you could jump past where you installed the old password and just change the new pin. You could change the pin without putting in the old pin by jumping to the fragment that went past it, so you could bypass things. That's the sort of thing that can happen. So it's a thing to be aware of. Those fragments are like extra activities, and you have to consider that. So there's a way to secure them. Since Android 4.4, apparently they're blocked anyway. So I guess it's not an issue if you don't target really old versions of Android. But if you do want to use them, you can allow a whitelist of fragments. And I think this is what you have to do now if you want to use them. They're blocked by default, and you have to specifically allow the ones you consider valid. And then only those ones will be accepted with a fragment at the end of the URL. And then, of course, you have to secure those as you would any exported activity. So you want to make sure that you understand what part of your app requires login and what part doesn't. This is the most common flaw in websites and also APIs, is there are functions that you should have to log in or log in as administrator first, and they forget to make sure, they don't all test to make sure you've really logged in as an administrator, so you can jump to some high privilege activity without really proving you have high privileges first. And so the main thing, that's the same thing here. So you should have some kind of app-wide authentication variable, where every time you enter anything, it can check to see, are you logged in? And in websites and APIs, they say the same thing. There should be a generic authentication method that you use all the time for everything. And the first time, whenever you get anywhere, you should go to the authentication method and verify who I'm authenticated as and decide whether I'm allowed to enter whatever function I'm entering. And you can mask password displays. This will prevent them from appearing on the screen when you type them, just dots will appear. So that's what you put there. All right. Browsable activities are ones that can launch to a web browser with just a schema like HTTP. You design some custom schema like Skype, and these are high-value targets for attackers. People can put links on web pages and such on. So if you use Browsable and accept URL-looking entries from anywhere, then you are opening your app up to attacks from anybody, and you have to be very careful to secure it. Skype got caught this way. A lot of people got caught this way because they took these kind of requests and did not secure them enough. And then there's content providers, your databases. In the early versions of Android, they were all exported by default. So to prevent that, you put in not exported. Exported equals false to make sure that doesn't happen if somebody installs it on an old phone. And you might have SQL injection, and the cure for SQL injection in Android is the same as it is in any other form of SQL. It's called prepared statements. So instead of building a query that says select something from where type equals data from user, you put question mark here, and then the user comes in as a parameter. So the data from the user is compared to the type, but it's not compared by putting it in a line of code with apostrophes that is parsed. This is a placeholder, and this is data. So this is a data object that will be compared to the type. It is not possible for this to be misunderstood as a code object. This is the perfect solution. No one's ever found any way to do SQL injection once you do it this way, and you do it in every form of SQL. You don't have type equals, quote, data from user, end quote. You just have a placeholder, and then this is called parameterized queries, prepared statements, where you have a parameter here that contains the data. And even if there's an apostrophe in that, it won't in any way be misunderstood and cause part of it to be interpreted as code. If you want to prevent directory traversal, which is of course a big issue, if you at any point you refer to a file, they might be able to use .. / and move out of the folder to some other folder. So before you use a file name with a path, you should make sure the path is correct. And there is a method here called getCanonicalPath that will retrieve the full absolute path to where you are from root/. And so here's, for example, is how you make sure you're in the files subdirectory. You go here and get the canonical path and then compare it to things to make sure that it really contains just the right directory. Starts with base folder, and the base folder is going to be the correct path. This is what you need to do if you want to avoid path traversal vulnerabilities. And we talked about this one before. It was in your projects. If you specify a path with a permission in the Android manifest file, and you specify the Android path, then it looks for exactly this path. And if you add just another slash to the end, it no longer applies this permission to it. And if you go into a subdirectory, it no longer applies this permission to it. So this Android path that looks easy to specify is probably not what you want. What you probably want is path prefix, which means anything starting with this, regardless of what comes after it, will be apply, or Android path pattern, where you can just have a regular expression describing exactly what you want, like anything that includes this anywhere in it. These are the ones you probably want to really restrict permissions. It would be a special case when you'd actually use the simple path. And you can define secret codes. We talked about these. You can define secret codes where you type in some phone number looking thing and it has some special effect. You can define them in your app. They're in the Android manifest. So it's an option if you want to, for some reason, allow people to do things in your app by typing in a number. The problem is you can't trust them to stay secret. Obviously, all you have to do is look in the Android manifest to see them. And anybody can download your app and look in the Android manifest. And there are even apps you can install on your phone that claim they will find the secret codes. So I'm not sure how they could do it without root permission. But anyway, the point is you can't trust them to stay secret, obviously. Your APK is public. Yeah?
Do apps have access to the other apps' manifest files? Like in the C++?
No, that's a good question. An app typically would not be able to read another app's manifest file. They'd be protected by the sandbox. Only root could. However, the user could just go on Android Google Play and download it and take it apart so they can find it. But yeah, normally, that's what I'm thinking. I haven't tried this app, but I think this app would probably need root permissions to work. Unless it just accesses a database of ones that humans are gathering and putting on the cloud. That might be it. But it would be interesting to take this apart and see how it works. I haven't done that. Be a fun thing to try. I did try over the weekend. There's a lot of news about Qatar, or Qatar, I guess. Qatar, the Middle East country, is having a sports event, the World Cup, and everybody that goes there has to install certain apps, and everybody's screaming bloody murder that those apps are unsafe. So I downloaded one of them, looked at it, and I didn't see anything that dramatic. They're just complaining about the permissions and stuff. But you have to give it your location, and you have to give them like remote control to read your COVID status. And that's the point. It's what we were supposed to have here. It's a COVID enforcement app that keeps track of your contacts. And if it decides you have COVID, it flags you and it tells the authorities and they know where you are and everything, which people regard as an intrusion in your privacy. But that's certainly what they have to have in order to work. Just like in China, then they'll send some guy to grab you and lock you up in quarantine. And, that's the whole point of it. It does violate American idea of freedom, but it's pretty understandable. That was my feeling. I didn't notice anything ridiculously, stupid about the app. It's just, of course, the primary intent of the app is something that offends a lot of people. Anyway, they said if you're going to go to Qatar, you should always use a burner phone. because the apps they make you install give the government in principle access to your files. And that might be true. The government claims, like our government would, that they don't abuse that access, they only do what they have to for COVID safety, but in principle, they are running sort of an MDM agent on your phone, which could in fact be used for other things. And phones what? Add your proxy? Can they do what to proxy? Act like a proxy. Oh, yeah, sure. Well, I mean, you can turn on the Wi-Fi sharing, and then anybody can connect to it, so then you're in the middle. And I guess if you get root on it, you could install a Linux proxy software. Oh, yes, yes. I mean, if malware on your phone can totally steal all the emails and send them somewhere else, and SMS and everything else. You could even just put a forwarding address inside your email account, like your Gmail. I'm sure you could, if you had root permission. Oh, they want to burn. Oh, they say you have to get a burner phone, and you have to not log into any of your accounts. So you take a phone just to like see the schedule or something, but they say if you can't log into your Gmail or your social networks or anything, or your email or anything, or of course they'll get that, right. So that's the, you'd be off the net while you're there. But people say, foreigners especially, do need a phone usually, so they can find their way around to get a translation app and stuff. But yeah, you wouldn't, if you do connect your phone to your usual accounts, then there's no point. Yeah, all right. Well, let's give it a shot. All right, so how do you stop tapjacking? What's that? What'd you say? Oh yeah, they took away the Halloween, because Halloween passed. Yeah, now we're back to the default. Right, so because it's not a Microsoft product, but a Google product, the names actually mean what they appear to mean. So filter touches when obscured means it's pretty obvious. That's what you want. If somebody's putting something on top of it, it will not interpret that as a click on your thing that is below.
Wait, you can do the screen too. This is new. They're changing stuff.
No, they got rid of the Halloween. This is the old screen, yeah. All right. All right, so how about fragment injection? Which components have that? All right. Carrie Lake is losing, apparently. I'm glad to hear that. She's the last of the MAGA candidates going down. All right, anyway, it's activities that have fragment injection, the pages. Not the content providers, but the activities. All right. All right, how do you stop SQL injection? Prepared statements, good. That accept data from the user as a data object which cannot be misunderstood as a code object. All right, so what path permission would fail to protect the subfolders? Just the simple one, path. Means what it says has to be exactly that path. That's usually not what you want. You mostly need this one, path prefix. All right. All right. Honey. All right. Good. All right. Good, we're on track. We can keep going. So, if you're going to store files, then you need to explicitly set permissions. If you open a file, you can have a private code. I'm not quite sure what this private does. Mode private. Afraid, nope, not obvious to me. I don't remember what the point of this is. All right. I have to look in the book. I've forgotten. Anyway, and the encryption I spent a lot of time worrying about. You should use AES for symmetric encryption if you want to use it and avoid electronic codebook mode. However, the problem with AES is you have a private key you have to hide somewhere. So logically, the only way I know to securely handle that private key is to derive it from a password the user has to type in. That's if you have to store the private key on the phone somewhere, which is what about half of all the apps do. That is just stupid beyond belief, and I spent many years humiliating companies for doing that. Now, asymmetric encryption is a fine idea. Use RSA at least 2048, and you'd be fine. Then you can have a private key that's on your server and not on the phone. However, I've never seen any app do this. This would make perfect sense. If you encrypted your app with a public key and stored that on the phone, you can only decrypt it with the server. That would be fine, but nobody does. The book is not, in my opinion, correct about password hashing. They aren't secure enough. You have to do salting and stretching. You don't just run it through something like MD5 or SHA-1. You have to add some random characters of salt and then run it through thousands of repetitions to make it slow. That's the right way to do it. But there are hashing algorithms to use, which is the best thing to use, secure hash algorithms like PBKDF2. All right, so random. This is something in all programming languages. The simple random number generator is miserable, and often it creates the same pattern of random numbers every time you use it. So you have to watch it random. In Java, if you don't seed it, then it will just repeat the same numbers every time. So you can write this Java code, which imports Java random and then prints out some random numbers. And then if you run it with an online Java tester, you'll always get the same answer every time. So it's, there is a better random number option to use, and that's secure random. And this is true of almost every programming language. There's 1, 2, or even 3 different versions of randomness, and you have to be careful which one you're using. PBKDF2 is one that does many rounds of hashing and can add a salt to a password, and this is the right way to derive a key from the password, and it's also the right way to hash a password for storage if you want to store a hashed password. But your key should be stored in the Android key store if you're going to store a key somewhere. All right, now if you want to store a file and you want other apps to see it, then you can specify that here as a provider. You can specify what permissions are required to see it, and then only the apps with that permission can get in, and that's fine. Then you're controlling who gets at it. And of course, secure communications we talked about. Don't use HTTP for anything. Everybody should use HTTPS, and should actually correctly use HTTPS and verify the certificate authority. Don't turn that off, or the HTTPS is not much good. Certificate pinning makes it even more secure, or even if a trusted certificate authority provides it, you then test another way to make sure that's still the right certificate authority, so that you'll bypass people that make a certificate even with a trusted authority to get in. Or, for example, that import another trusted authority on the phone like we did with Burp. Then it would pass the original test, but you can do certificate pinning, and then it will not pass even that. If you're going to transfer data from one app to another, using the API with activities is the best method. You have an intent filter listening, and you send an intent from the other app. There's more recent Android versions, there are other ways to do it. Choose your targets, shortcuts, direct share targets. These are just other ways to send data from one app to another. You can use network sockets or the clipboard to move data from one app to another, but those are less safe. Other apps can get in there. And web views, we talked about. Web views are the browser-like things that you put inside your app, so your app can open a web page, and they often lead to problems. One thing, make sure that you have content. Make sure you have your stuff loaded over HTTPS, of course. Disable JavaScript if you're not using it. Disable JavaScript interface if you're not using it. If you are using it, make sure you're using a later SDK. Disable plugins. There used to be Adobe plugins and such. They've been deprecated. I think you can, in principle, still use them, but unless you need to use them, don't. They're all pretty unsafe. Disable file system access. This is important. Otherwise, somebody can send a path to a file and get out and access files on the file system. You normally don't need that. It's just a directory traversal vulnerability. And if you download any content from the web, it's a good idea to validate it. Make sure it's really coming from a trusted source. If possible, verify the hash value or something else on the page to make sure you're really getting what you should be getting from it, because people can tamper with the web traffic and feed the wrong thing in. All right, and the Android manifest. It's got a lot of stuff in there. So if you allow the backup, then people can back up files, and you consider whether you want to do that. You might want to deny that option. Then, of course, the user can't back up their files anymore, but then the bad guy can't either. And there's debugging. You don't have a project where you use debugging. That would be nice, but debugging is pretty powerful. It'd be fun to have a project on that. I might be able to get one together, but it doesn't look like I'm going to have time to do it this semester, though. And you should target as high a SDK version as possible. If you target an old SDK version, then your whole app security is lowered down to that level. Of course, if you only target a new SDK version, then people with old phones can't use your app, so you have to find a happy medium. All right. If you target an SDK 28 or higher, then you must have Android 9 to use your app, but then you get all sorts of good features. You get encrypted DNS lookups. You get everything has to be TLS. You can't send any clear text traffic by default. You have separate web view directories for each process. So even if somebody could inject code in your web view, they can only steal cookies from that app, not from any others. That's good stuff. That's the kind of stuff you get. And you can use Cloudflare's private DNS 1111 with DNS over HTTPS on Android 9. So if you do use Android 9, you get a lot of nice features. And now we're up to 11. I imagine there's even more new features. All right, you should just not have any logging in your release build. In principle, it might be okay if you're not logging anything sensitive, but it's considered the best practice to just not log anything in a release build. So have a centralized logging parameter where you can just turn logging on and off with a single parameter to make it easy. And ProGuard can remove this. We'll talk more about that in a minute. If you make native code is like C or C derivative program compiled running on the device, just like compiled Windows apps. And that, of course, is difficult to secure. It's got all these security problems, like buffer overflows and all these others. So if you're going to do that, then use the latest development kit version. And there's a script called checksec you can use. This works for Linux apps. We use it in the exploit development class. This will check to see if you have any of the serious security vulnerabilities here. This will check if you have relocation read-only. If you take the exploit development class, we use this a lot. If you gain write access, which is what you get, for example, if you have a heap overflow, you gain the ability to execute a write operation. To take over the phone or take over the computer with a write operation, you have to write to an address that will be used to redirect code, and those are the relocation records. There's a relocation table which lists an address which goes to all the C libraries, like stop and open network socket, exit and everything, and you can relocate those, and then when that C call is made, it will jump to your code. So this will make those all read-only, so nobody can write over them while your app is running. That protects that kind of attack. Stack canaries prevent the classic buffer overflows, the ones Aleph Null wrote about 25 or 30 years ago, which were the bane of all Windows apps right up through Windows XP, all Windows operating systems. And it puts a stack canary on the stack frame, so if somebody overflows a string variable, they cannot get to the control variables to control the code execution without overriding the canary value, which is named after a canary in a coal mine, which was used in a cage to detect poison air in mines. NX means that you have an area of memory that is non-executable, and that's where you put your data. So even if a user is able to inject code there, they won't run because that area is not executable. Pi is position-independent code. This is code that can be randomly relocated in memory. So if you have address space layout randomization, then the attacker does not know where you are in memory, and that makes it very difficult to jump to code they inject. Even if they're able to inject code somewhere where it will run, they can't find it. RPath and RunPath are parameters set during compilation that specify where it's going to look for libraries, and if these parameters are turned on, then it will hunt through the path for libraries instead of looking in the right place, and that allows you to have companion Trojan attacks where you can put a false library in an earlier spot in the path, and your app will load the wrong library. So these should be turned off. So this is the good value you want to find here, is no RunPath and no RPath. All right, that's a good script, and it's good to know what all those are. So like I say, here, our relocation read-only prevents global offset table rewrites. Run path allows people to put modified libraries in a different location and have them load, and so you don't want either of those. And a lot of them are turned on. A lot of compilers have these things turned on by default, so this check sec will tell you if your compiled code really has all the recommended security features turned on. All right, and then there's other mechanisms like, remember, it's a protection level downgrade. For old versions of Android, you could define a permission first, and then if another app comes and tries to redefine the same named permission, it will leave the old permission setting there. So that's kind of nasty. Your app inherits that level. So your app can check in your code to make sure that protection level is intact at the entry point. Attackers with root permission can access the non-exported components. We talked about that. So even if you don't export things, the root app can get in. You can actually add a token to prevent that if you want to, stored in a variable in memory where intents have to have that token. So the intents have to come from your app, and the attacker would have a hard time finding that to get in. Probably is not impossible for someone with root permissions, but it's another obstacle to block weaker attackers and slow them down. Really, all you can do with people with root permission is slow them down. And that's what a lot of these things here do, slow down or reverse engineer. Obfuscating the code. ProGuard is the free one that comes with Android Studio. It's very ineffective. It renames a lot of apps, a lot of files and variables A, B, and C, but only some of them. All kinds of useful ones retain their old informative name. DexGuard is the paid version, which I've never used. Dash-O is good. It's expensive, $3,000, and it has a 15-day free trial. So when I ran Dash-O, and one time I had a project here where you get to play with Dash-O. I don't think I have it in the latest version of the course, but it turns all your variable names into this garbage, just like 20 random punctuation marks, instead of saying like password or credit card number or anything like that. So that'll slow you down. You can't tell what anything is. And so what you have to do, I've written code to do this, I've written Python code that will go through and just log everything. And then to turn on the app, it runs slow, everything screams through the log. Now you find like the credit card number in there, then you can figure out which one of these things it is. But it slows you down. It makes it much more annoying. And we've seen these in the projects. You can have root detection that detects if you're running root. A lot of apps will warn you, don't run as root, or even just refuse to run at all, saying we will not run on a rooted phone. So to detect that, here's some ways to do it. Look for packaged common root files. I think I'll shut that window, that door, we don't need it. Anyway. All right, and so you can look, similarly, you can look for files that tell you you're in an emulator, just like malware will detect if it's in a virtual machine. And of course, it's not perfect, but it can look for things that are clues that you're in an emulator. You can look to see if your app is in a debugging environment the same way. And these will be things you can try to make sure you do not run in these dangerous conditions. And you can check the signature to see if anybody is modifying your app. And we saw that Indian government app did this. It checked for a hash value. You can also check the signature and make sure the signature has the expected value. And so, of course, the problem is, just as we did with that Indian government app, you can just modify the code and disable the detection. So you could argue it doesn't accomplish anything, but I don't think that's fair. This is the way all security barriers are. You put up a barrier, there's always an attacker that can get through, but the weaker attackers don't get through, and that's all you ever accomplish, is you stop the weaker attackers. They're powerful attackers like enemy military. You're not going to stop them with anything you do, so you just have to have reasonable threat modeling. And then you can decide whether the cost of your defense is justified by the amount of real attacks it's going to stop or not. That's the issue. Anyway, let's take a look at another Kahoot. Plug in my power. All right, people still coming in. I'll continue getting the power cable. All right, so what prevents Stack Overflows? And like I say, with 126 and especially 127, we go through this in great detail. Anyways, what's that? Exploit development. Yeah, exploit development is where you perform these attacks. Yeah.
Are you teaching next semester?
Yes, supposedly. I asked for it, and now the official list has not come out yet.
I think it's out today.
Oh, is it? Oh, good. Well, then I should check. Here's what I asked for. So, oh, good. If the list is out, I can check. But theoretically, it's coming next semester, and so yeah, you might like it. Anyway, it's fun to do these attacks, and you really learn all the defenses then when you've really had to punch through them. All right. So the canary is what waits at the end of the stack to make sure that nobody has been overrunning the boundaries of arrays. All right, so what function will create a key from a password? It's there? Good, good, glad to hear it. I imagine they gave me what I asked for, or they would have told me, but I wish I should look and see what I actually got. That's it, password-based key derivation, function number 2. That's the main one people use to turn a password into an encryption key. And all it does is run a hash function many times and then pick off a certain number of bits to make your key. All right, so what defense makes Smalley difficult to read? That's obfuscation. And the point of this is makes your code almost like compiled C code. If you compile C code, you can strip the symbols, and then you don't have the names of the methods or the names of the variables. And that's what this does. It takes, scrambles them all and turns them into like random letters, so you cannot tell what anything is by just looking at it. All right, what mechanism will make HTTPS more secure? Yep, that's it, pinning. Make sure that the certificate is the right certificate, even if the attacker has managed to overcome the standard HTTPS verification technique. So, that's Rouhani. All right. All right, next, I know who that is. I know who that is. All right, good. So let me stop this recording.